Okay, so today I want to go over a cool video, basically how the internet works. So I just really think the internet is fascinating and computers are fascinating. So I just want to go over, I thought it'd be cool to do a high level video of basically explaining just just an overview of how the internet works and kind of what's going on. So I mean, I just think, like I said before, it's fascinating because when I first started messing around with computers, I didn't understand it at all. It was just a black box, and it did magic. Um, but when you get to the low level and you start learning kind of how the computer works, it's pretty fascinating. I mean, the reason why a computer can do what it can do is basically about is because how fast electricity can travel. So electricity can travel. I think the speed that they usually go with is that it can travel around the world. It's like three times in 1 second. It's hard to really wrap your head around it. But I've learned that a computer, like obviously it's still complex, but it's just the way it can do things is because of the speed. It just does things so fast. It's just incredible because when you get to the low level, I mean, electricity, the flow of electrons, you're just turning that flow of electricity into pulses of ones and zeros, and you're just creating code. You're just creating a message. And let's just say the letter A is 00010, and I can just send a pulse of electricity, a combination across a wire, and tell you that, that's the letter A. And you go up from there, and it's just really fascinating. So I'm going to start off with a web page here. Just go over a high level example here. I think it's pretty fascinating. So you'll have your web page, and this will be like your URL. Let's just say www. Let's just say ytube.com, YouTube, whatever. Okay, so what happens when you enter this site into your browser? So the browser basically takes files, boring files, and converts them into something pretty and nice. So when you type in in your web browser that URL, basically your router doesn't know where that is. YouTube.com, ytube.com, it doesn't know. So it needs to find out because routers and switches, they know IP addresses. IP addresses are just the addresses where the server or the computer is at. So every computer or every server or machine on the internet has a unique IP address. Now on your local network, that's a different story, but your machine right now, if you go to google.com and say, what's my IP, that address is going to be unique to every machine on the internet. Now, that's why we had the battle of IPv4 versus 6, IPv6. So when they first created the internet and the protocol for the internet, they came up with the IP protocol version 4, which is basically a certain amount of bits to store a number, an IP address. And it's getting to the point where we have all these devices connected to the internet, and there's just billions and billions of devices those numbers we're running out. And there's other ways that we've got around this, and we're still kind of okay with IPv4. But when we first created the internet, we didn't think it was possible to have that many IP addresses on the internet. And now we're kind of getting to that point, so that's when they came out with IPv6, which is just a bigger bit, which allows us to store a lot or contain a lot more IP addresses. I think it's 32 versus, I don't know if it's 128 or 64, but you kind of get the point. So anyways, we don't know what youtube.com is, so we need to get an IP address. Because we need to send a request, because this right here, this request is going to basically be, I want your homepage, index.html. We want to get that. That is our request, okay? But we need to know where to send that request. So that's where we need to get the IP address. So basically what we're going to do is reach out to, usually it's going to be your ISP, but it's going to be your DNS, your domain name server. Now, this could be, you could change this to whatever you would like. You can use Google's DNS servers. A lot of times this will be your ISP though. Your internet service provider like Comcast. They'll have the DNS server. So basically whenever you have a request and you type in a URL and you need to say, hey, what's the IP address for this? You're gonna go out. Now basically you're going to connect to your router. So you're gonna take that data, you're gonna pass it to your router. Your router says, okay, I need to go out into the internet or to my ISP. So it is going to go to your ISP and search the DNS. I'm gonna put the DNS here actually. The DNS is like, or the domain name server is like an encyclopedia. It's gonna search for this URL, find the IP address associated with it, and say, okay, this is the address that you need to send your data to, and it's going to send back the IP address. And obviously that's going to go through your router and then back to your machine. And now that you have the IP address, you're going to build up a packet. Now in the olden days on the internet, it was basically called circuit switching. So kind of like when you had a telephone. Okay, this is my art skills here. It was just basically you had one circuit or one connection that was made and your data would go back and forth. But now it's not like that. It's breaking up, and it's called packet switching, breaks up your data into little chunks called a packet. And your data is not going to be in one big packet. Like I said, it's going to be broken up in little chunks, and every packet can take a different route to the IP address to the destination. Yeah, so the backbone of the internet, you have your ISP who basically reaches out, and most of the internet is cables. So most of it's underground cables. Like these cables might be fiber cables that go under the ocean. That's how we communicate across countries, and we're all connected. It's almost like a spider web. It's pretty fascinating. And it's the combination of wireless networks and towers with underground cables. A lot of fiber nowadays. Fiber is going to be the faster of the cables. But anyways, so back to, want to go to youtube.com, type in that URL, goes to your internet service provider, and your actual domain name server that they have is like an encyclopedia. It says, hey, youtube.com, what's the IP address? It finds that IP address, sends that back to you. This is what happens when you send a request. And then now that we have the IP address, we can build a packet up, which will have the destination IP built into it, where you want to go. It'll have your IP. And I'm not going to dive deep into this. And obviously, it'll have a chunk of the data. It'll have a lot more stuff into that little packet. But it's going to break it down into a lot of packets. And then it's going to send it to your router. Your router is going to go to your ISP now that we have the address. And then their router is basically going to choose, hey, what's a good route to go? Now, this route could go to some random router over here. Now, YouTube.com, a lot of these big companies or big websites, they might have multiple servers over the country and across country, because obviously we don't want all the requests going to one server. and especially if it's far away and there's one closer to you. So they spread out these servers. That way it spreads out the workload and you can get your information faster. So youtube.com goes to the DNS. It might go through a few hops, and that just means it hits a router. Let's say at your university, might go through your university, hit there, and keep going on, and then finally we get to one of YouTube's servers, and they're going to get that request, and they're going to say, okay, you want the homepage to youtube.com. Now, that page, usually a page is going to be filled with 3 main files. So in the olden days, it might have just been an HTML, but now we have a CSS and we have a JavaScript, usually. These are going to be your 3 main files you're going to have. So it has a home page which consists of 3 files. HTML, that's just the structure, tells your browser the structure of the web page. CSS tells you the style, like the color, font size, and the images. And that's usually loaded last. That's why when you load a web page, you'll see the structure and maybe the text, but maybe sometimes the color or the images come in last. And that's because CSS, if you have a good programmer, that should be loaded last. And then your JavaScript. Your JavaScript is basically functions that can be processed on your machine. So I'm going to send this back through here, and then I'll go over that. So we're going to break this down into chunks, into packets, and we're going to send this maybe a different route. We're going to go through a couple routers and a couple hops, and then we're eventually going to get back to your router at home. And that router is going to say, hey, I know where that's at, send it back to your machine. You're going to get that HTML is going to load in, and your browser, Chrome, whatever, gets these files, and it knows how to convert them and make them pretty. JavaScript. It'll load your HTML and then your CSS and your JavaScript on your page. Okay. So another thing that we'll go over real quick is security, just a high level. So usually now the standard is going to be WPA2. It's all through basically encryption, because basically if you were, this is your home router. If you were on a network, let's say McDonald's or something like that, or even at your home network, and somebody, let's say you had WEP, which is the old standard, and somebody can hack into that easily. We don't want to use that though. They could get on your network and get their laptop open and use a packet sniffing software such as Wireshark, connect to your internet and basically sniff and read your packets. So that's where on your network or whatever network you're connected to, you want to have good security such as WPA2, which is the new standard. And then anything beyond that, because obviously you got that, but once you go out into the internet, that's a whole different ballgame. Your data is not really protected. You don't have control over that. That's where you want the HTTPS or secure, and that's all done with encryption. That's going to take your data, your packets, and encrypt them, basically so that they can travel. Once you get past your home network, they can travel throughout here. And if somebody were to sniff those packets, they have no idea. They're encrypted with a lock, and you're basically, whoever put that lock on there has the key, such as YouTube or your bank or something like that. So encryption is important. Your own Wi-Fi local network is important to have the WPA2 and good standards put in place. But when you think about the internet and your data being broken down into chunks, and then getting into a destination, going through all these routers, and it could take a lot of hops to get there, you just think about your data and how it's just being thrown out there on the internet. I mean, security and cybersecurity is getting huge because we need to protect that kind of stuff. Okay. So I think that's a good high-level overview of the internet. Hopefully that wasn't too sloppy for you guys. If you have any questions, leave some comments below. Thanks for watching.